Good afternoon, everyone. Today
Good
we
afternoon,
shall
sir.
today we shall take up Chapter 3, Interior of the Earth, of Fundamentals of Physical Geography. Now let me present. So this is the chapter Interior of the Earth, Chapter 3 of your NCERT textbook, Fundamentals of Physical Geography. So you also have already learned in the lower classes about the Earth interior. What is the nature of the Earth interior, whether it is in solid state, whether it is in liquid or in other forms. And you may be learning different layers of the Earth interior also. Then how the scientists, the geologists know about the nature of the Earth interior. Okay, for that we need to collect lot of data and information about the Earth interior so that we can derive the inferences. So here in this section, okay, in the beginning we will learn about the sources of information about the Earth interior. We are going to learn two main sources of the Earth interior. The first one is direct sources and another one is the indirect sources. Okay, see here one important line is given here. The interior of the Earth can be understood only by indirect evidences, as neither anyone has nor anyone can reach the interior of the Earth. That means the Earth interior is opaque. We cannot see what is there in the Earth interior, and we also cannot go deep into the Earth interior. And that is why most of the data and information about the Earth interior are obtained through these indirect evidences. However, some direct evidences are also there. Now let us see. See, it is also mentioned here, okay. Most of our knowledge about the interior of the Earth is largely based on estimates and inferences. And yet a part of information is obtained through direct observation and analysis of the materials. That means we are going to learn about the direct sources of the Earth interior. Okay, direct sources of information about the Earth interior. So what are the direct sources? Let us see. So the first important direct source is mining. Okay, so from the mining areas, okay, so we get different types of rocks, and we also know the nature of the these materials. Okay, and so this is also one of the most important sources of information about the Earth interior. You know, we have two main types of mining. Okay, one is the surface mining, another one is underground mining. Okay, in the case of underground mining, we have to dig very deep tunnels, and from that tunnels we can collect data and information about the Earth interior. Say for example, see gold mines in South Africa are as deep as 3 to 4 kilometers. Okay, See, going beyond this depth is not possible as it is very hot at this depth. That means when we go into the Earth interior, okay, so let me draw. So for example, this is the surface, and here we have the these minerals. Okay, so to take out minerals we have to dig sharp tunnels like this. Okay, and after that we can take out the materials from here. So gold mines in Africa are as deep as 3 to 4. Okay, these 3 to 4 kilometer deep. So from this mining area, okay, from this tunnel, we can collect data and information about the Earth interior. However, going beyond this 3 to 4 kilometer is not possible, because if we get down into the Earth interior, temperature is increased. Okay, at the rate of this 1 degree for every, at the rate of 1 degree, okay, 1 degree Celsius for every this 30.4 meter. If you get down into the Earth interior for 30.4 meter, then temperature is increased by 1 degree Celsius, and that is why we cannot go deep into the Earth interior. And that is why we can collect this about information about the Earth interior only say from 3 to 4 kilometer deep areas. Okay, directly. So another important this direct source of information say is project. Okay, so projects to penetrate deeper depths to explore the conditions in the crustal portions. So some geologists, okay, some geologists of the world are trying to get information about the Earth interior by drilling into the Earth interior. Not for mining, okay, simply let us say this is the Earth, okay, this is the Earth interior, and some scientists are drilling deep into the Earth interior, okay, using drilling machines. Okay, so using these drilling machines, and they are making holes in the Earth interior and collect information. So these are known as drilling projects. So we have examples like this deep ocean drilling project, that is drilling on this floor of the ocean, and the integrated ocean drilling projects. So these are the two important projects taken by scientists to collect data and the information about the Earth interior. Okay, so we have example C. The deepest drill at Koala in Arctic Ocean has so far reached a depth of 12 kilometers. That means scientists can make a hole, okay, in the Earth interior up to 12 kilometers. However, you know, the this radius of the Earth is 6,370 kilometers. This is the radius of the Earth, but we can drill only up to these 12 kilometers. Remember, okay. However, this deep drilling project have provided large volume of information, okay, through the analysis of materials collected at different depths. So this is the second direct information, and the third direct information is volcanic eruption. Okay, any question from your side? Do you see my screen?
Yes, sir.
Okay, so another this direct source of information about Earth interior is volcanic eruption. Everybody knows about volcanic eruption. We have watched National Geographic channels, YouTube channels, okay, and in the televisions also. So volcanic eruption forms another important source of information, direct information, okay, direct source of information. See here, as and when the molten material that is known as magma is thrown onto the surface of the earth during volcanic eruption, it becomes available for laboratory analysis, okay. And so from that also, by analyzing the magma, by analyzing the lava, we can also say get some information about the nature of the earth interior. So these are the three important direct sources of information about the earth interior. The first one is mining. The second one is deep drilling projects, and the third one is volcanic eruptions. So these are the three important direct sources of information about the earth interior. Do you have questions about these direct sources of information? Do you have a question? Okay, so let us proceed. Next we have these indirect sources of information, okay. See, the first important indirect source information is meteors, okay. So can any one of you tell about meteor? What is meteor? What are meteors? See, I will show you one picture, okay. See, this is a meteor, okay, as an object flying in the sky. Actually, meteors say are meteoroids, okay, are derived from these objects, actually lump of rocks called meteoroids, okay. See here, meteoroids. I will meteoroids. See, meteoroids, these are these big lumps of rocks, okay, moving in the space, and they are orbiting around the sun also. And when these lumps of rocks known as meteoroids happen to enter the earth atmosphere, it is burned due to friction, okay, and it appears like this. When it enters, when the meteoroid enters the earth atmosphere, it is burned due to the friction with the air, and so it is like this. And sometimes if this meteor is big, then it may not be able to burn totally, and that is why the remnant of meteor may reach the surface of the earth, and that is called meteorite, okay. And this meteorite is available for us for laboratory analysis. See, this one, actually, you know, these meteors are not derived from the earth interior, but see, actually when we learn about the origin of the universe, origin of the solar system, then all these heavenly bodies in this space are derived from this source, from a common source. And that is why I say by analyzing a meteor, we also can understand what is there in the earth interior. So it is also mentioned here. See, it may be noted that the material that becomes available for analysis from meteor is not from the interior of the earth. That means meteors are not from the interior of the earth. The meteor and the structure observed in the interior in the meteors are similar to that of the earth. However, the material, the structure observed in the meteors are similar to that of the earth, because earth and other planets, then other asteroids and other heavenly bodies were derived from this common this object. Okay, and that is why. And they are solid bodies. These meteors are solid bodies developed out of materials same as or similar to our planet, and hence this becomes yet another source of information about the earth interior. Okay, so by analyzing a meteor, we also can infer about the earth interior. Any question about meteor? Do you have any question about meteor? Any question? Actually, this was a very big meteor over Russia. Okay, in 2013, a big meteor hit Russia in 2013. Okay, and this is the photograph of that meteor, and it caused a lot of destruction. Okay, in Russia in 2013.
Sir, one question.
Yes.
Why the meteors they are floating in the space, but sometimes they used to fall down? Why?
Actually, these meteors, okay, they are irregular in shape also, and see, they are orbiting this round the sun, and their path, okay, their orbit are also not regular, just like the other heavenly objects or like planet. Even the planet also, their orbit is changed from time to time. Okay, in the later period you will learn about Milankovitch oscillation also, that the path of the this planet also changes from time to time. And likewise, these irregular objects also, okay, their path also changes from time to time. And when they change their path due to some these forces, okay, so it enters our this atmosphere. So may be attracted by the gravity of the earth. Okay, because they are irregular also, and so they are moving in space, and if another small object hits on it, then it may change their path also, and that is why it enters. Okay,
Thank you, sir.
then let us proceed. These other indirect sources include gravitation, that is gravity of the earth, then magnetic field, then seismic activity, that is earthquakes. Okay, so these are the three other indirect sources of information about the earth interior. So the first one is gravitation. The gravitation force G is not the same at different latitudes of the surface. The force of attraction of the earth is not the same everywhere. Okay, it is greater near the poles and less at the equator. This is because the distance from the center at the equator being greater than at the poles. You know, the shape of the earth is not round. Okay, actually it is geoid. It is flattened at the poles. It is like this. See, the shape of the earth is like this. It is flattened at the poles. And let us say this is the equator. Okay, and here let us say this is actually, let me draw vertical. Okay, this is the axis. Actually axis must be inclined, but for the time being let me draw in vertical. And see here, if you compare the distance between the pole and the center here, distance between the polar area and the center, and the distance between the center and the equator, if you compare, then this one is greater. Okay, when we compare the distance between equator and the center and the pole, it is greater at the equator, and that is why gravity is less here. Okay, you will find less gravity at the equator as mentioned here. See, this is because the distance from the center at the equator being greater than that at the poles. Okay, the distance at the equator is greater than that of the poles, as you have seen in this diagram here. The distance is greater, and that is why gravity is less here as compared to the polar area. Okay, so gravity values also differ according to mass of the material. The uneven distribution of mass of material within the earth influences this value. See here, gravity value also differ according to the mass of the material. And you know that the distribution of material, okay, the distribution of the mass of the material is also not the same everywhere, and that is why the gravity value also differs. And see, the reading of gravity at different places is influenced by many other factors. Not only the mass of the material, the gravity may be affected by the other factors also, and these readings differ from the expected values, and such difference is called gravity anomaly. Say for example, here say we have this, one may expect a higher gravity value here, okay, theoretical value. A scientist may expect a higher gravity value here, theoretically, but when they measure the gravity, then they may find it low gravity value. That means we have got a difference between the expected value and the actual value, and this difference between the actual value and the expected value is known as anomaly. Okay, gravity anomaly, as mentioned here, gravity anomaly. So gravity anomaly is the difference between the these expected values and reading values. Okay, and gravity anomalies give us information about the distribution of mass of the material in the crust of the earth. So by analyzing the gravity anomaly, we can understand about the nature of the earth interior. Okay, that means about the density or the nature of the earth interior by analyzing the gravity anomaly. Then we have these magnetic surveys. Okay, see, also magnetic surveys, you know, say earth, it has magnetic properties. Okay, also provide information about the distribution of the magnetic materials in the crustal portion, and thus provide information about the distribution of materials in this part. You know, these magnetic properties, okay, are related with these materials of the this earth interior also. See, it is much related with the materials like iron, then nickel. Okay, so by analyzing the magnetic values, okay, magnetic properties of the earth interior, we also can understand about the distribution of these materials in the earth interior. So in this way, magnetic these surveys also provide information about the distribution of materials in the earth interior. And next, the fourth one, okay, seismic activity. Seismic activity means earthquakes. Okay, is also one of the most important sources of information about the earth interior, and hence we shall discuss about earthquakes in detail. So before we discuss about the earthquake, do you have any question regarding these indirect sources of information like meteors, gravity, then magnetic field? Do you have question? Do you have question?
No, sir.
Okay. So before we discuss about earthquakes, okay, as a major source of information about earth interior, we have to learn what is an earthquake and how does an earthquake occur. See here, earthquake, you know, this earthquake means shaking of the earth. I think all of you might have experience about earthquakes also. So earthquake refers to the shaking of the earth surface. And if we study these earthquake waves, okay, we can have a complete picture of the layered structure of the earth. Then now let us see why does the earth shake. That means how does an earthquake occur? Let us read. Okay, the release of energy occurs along a fault. So earthquake is occurred when there is release of energy along a fault. And so what is a fault? Let us read. Okay, a fault is a sharp break in the crustal rock, and rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes a release of energy, and the energy waves travel in all directions, and in this way earthquake occur. Now let me draw a diagram. Okay, see here. Let us say these are the different layers of the earth interior which were formed in a particular geologic time. So this is a formation, a layer, okay, which was formed in a particular geologic time. And so this is another layer, okay, another formation which was formed in another this geologic time. So this is another layer. Okay, and you must know that in the earth interior there are so many tensional forces. Okay, so the rocks in the earth interior, they have these tensions among themselves. Okay, and because of these tensional forces, sometimes some part of the earth interior may be slided like this. It may be slided, okay, like this. So this is these are the layers, and so because of this faulting process, okay, here this portion is subsided, and so the first layer comes here, and the second layer comes here, and this is the third layer, and the third layer comes here, and this process is known as a faulting. Okay, so this process is known as faulting, and it is caused by the tensional forces among the rocks. Okay, and when there is this faulting, energy is released along this fault plane. Okay, energy is released here as given in the book. Okay, energy is released, see here, when there is deformation, that they slide past one to one another abruptly, and this causes release of energy. And because of this release in energy, then see these arc waves propagate in different direction, and because of these waves the earth surface is sagging and trembling, and that is called earthquake. Okay, so that is what mentioned here in your book. And the point of origin, okay, the point of origin of the earthquake is known as focus. The point where the energy is released is called focus, and it is also known as hypocenter. And the energy waves traveling in different directions reach the surface, and the point on the surface nearest to the focus is called epicenter. So let me show you another diagram. Okay, see here, see this diagram, and here faulting is taken place here. Okay, this is the faulting process, that is the subsidence of a part of the earth crust, and because of this subsidence energy is released here, and the point where the energy is released is called focus. Okay, the point where earthquake is originated is called focus, and it is also known as hypocenter. And the point just above the focus on the earth surface here is known as epicenter. Okay, here the point just above the focus on the earth surface is known as epicenter. Any question from your side about the original earthquakes, about focus, about hypocenter, epicenter? Any question from your side? Any question? Nobody is responding. Are you connected?
No, sir. No question.
Okay, then for today let us stop here, and as usual please send your name in the WhatsApp group for attendance. Thank you very much for joining my class.